another question on representing the bearing of one point from another on a diagram. Let's take the question for this video. The bearing of point C and point D from point A is 65 degrees and 120 degrees respectively. Illustrate this information graphically or illustrate this information on a diagram. We have the bearing of point C and point D, and both of these bearings are taken from point A, and the angles are 65 degrees and 120 degrees respectively, and we are supposed to represent this information on a diagram. Reading the statement carefully, we can see that we have this word respectively here, and we have been given two angles, 65 degrees and 120 degrees. What this means is that the 65 degrees belongs to point C and 120 degrees belongs to point D. So the bearing of point C and point D from point A is 65 degrees and 120 degrees respectively, meaning that the bearing of point C from point A is 65 degrees and the bearing of point D from point A is 120 degrees. That is the meaning of the word respectively that has been placed after 65 degrees and 120 degrees. So from this question, we can see that we have two bearings here. The first one is the bearing of point C from point A, which is 65 degrees. And the second one is the bearing of point D from point A, which is 120 degrees. And we are supposed to represent these two bearings on the same diagram. So when you have this, how do you do it? Let's find out. We are going to begin with the first one, the bearing of point C from point A. We said that in order to represent this bearing, what you need to do is to find your starting point. Our starting point is A, point A. Our ending point is point C, and the angle is 65 degrees. So you draw your diagram. Since this is a 3-point bearing, I will draw the diagram with the angles on it. So 0 degrees, 90 degrees, 180 degrees, and 270 degrees. As we become more conversant with drawing this diagram, I'll remove the angles. For now, I use the angles so that you can see which quadrant or which area the line is going to fall. Okay, so let's begin with the first one. The bearing of point C from point A is 65 degrees. We've done quite a number of this, so I'm sure that by this time you should be able to draw for the first one. The bearing of point C from point A is 65 degrees. On this diagram, it will be illustrated with this line. So you measure 65 degrees from 0, since 65 degrees will fall between 0 and 90 degrees. So 65 degrees will fall between 0 and 90 degrees. So from 0 in the clockwise direction, you measure 65 degrees, then you draw the line. So this is our starting point, point A. We have drawn the angle on the diagram, 65 degrees. Our ending point is point C, so you indicate that on the diagram. So we are done with the first part. The bearing of point C from point A is 65 degrees. Then you move on to the second part. The bearing of point D from point A is 120 degrees. So you see that this time, our starting point is still point A. We already have point A here, so we are not going to draw another diagram. It will be on this same diagram here. Our starting point is still point A, but our ending point is point D, and our angle is 120 degrees. So it means that we are going to measure 120 degrees from this point here, which is point A, on this same diagram that we've drawn here. Okay, 120 degrees will fall between 90 degrees and 180 degrees, which means that the new line or our new bearing will be in this area or in this quadrant between 90 degrees and 180 degrees. So you ask yourself, what should we add to 90 degrees to get 120 degrees? And we are going to get that by subtracting 90 degrees from 120 degrees, and that is going to give us 30 degrees. because 30 plus 90 will give us 120. So it means that if you want to get the second bearing, that's the bearing of point D from point A, you have to measure 30 degrees from 90 degrees in the clockwise direction. So you measure 30 degrees from 90 degrees, then you draw the line. So once again, we have our starting point A. We have the angle 120 degrees drawn. Then our ending point is point D. So